Hello bachon, let us read the question first. Find the position of the maximum and minimum ordinates of the curves. Y is equal to x minus 1 into x minus 2 into x minus 3. To solve this question, first of all, we'll write some key concept first. Key con- Now, after writing the key concept, we'll use that concept to solve this question. Okay, so first of all, we need to understand the critical point here. The critical is the point where the slope of this curve will be equal to the 0. It means, first of all, what we'll do here, suppose we have to find the critical point of any curve like ax square plus bx plus c is given. And we have to find the critical point. Then what we'll do here, so first of all, we'll take the first derivative of this equation. That will be 2ax plus b. And then now we'll equate it equal to the 0. And then we'll try to find out the value of x, that is minus b by 2a. So this is the critical point at which this curve will give the 0 slope. And after that, what we'll do, we'll again differentiate with respect to x, and then we'll check after putting this value into that equation. If this value, if d2y by dx is square is positive at that particular x, then what we can say at the times? If it is negative after putting the value x, after putting x, if it is negative, then what we can say? It means it will be giving the maximum value at the point x. So giving maxima, maxima at x. Similarly, if it is giving the negate positive value dx square at x, if it is giving the positive value, then it will be the minima at that point, giving minima at x. So we'll use this concept to solve this question. So first what we have to do, first we have to differentiate with respect to s in order to find out the critical point. So let's try to find out. So we have a y is equal to x minus 1 into x minus 2 into x minus 3. So we know that whenever such kind of the function is multiplied, so we'll take in that case a log. So taking the log on both sides, taking a log function on both sides, function on both sides. Let's take log. So log y is equal to log. So here what we need to know one thing is that whenever the log m into log n into log p is given, so we can write this function as a log m plus log n plus log p. So suppose here I will write formula first. Suppose we are given the log m into n into p. Then what we can write here? So we can write the log m plus log n plus log p. So the same concept will apply to solve this further. So let's solve. So the log y is equal to log x minus 1 plus log x minus 2 plus log x minus 3. So now we'll differentiate it with respect to the x. So we'll write the differentiating with respect to x. Okay, so let's differentiate. And then what we get? So we know that the differentiation of the log y is equal to the 1 by y. But here we are differentiating with it with respect to the x. So there will be one more term, that is the dy by dx. Now we'll take again the differentiation of this function. So what will be the value of log x minus 1? So it will be the x minus 1. And again we'll differentiate this because it is not in basis form. So here into 1. Okay. So plus. again we'll differentiate this because the differentiation always follows the distributive law. So it will be distributed throughout this word, through these all terms. So here we'll get the 1 by x minus 2 to 1 plus 1 upon x minus 3 into 1. Oh, so what we'll get here? So we'll write again it. So suppose we'll change the pen, and the 1 by y we have here on other side, dy by dx, and we have found the value like 1 upon x minus 1 plus 1 upon x minus 2 plus 1 upon x minus 3. What we'll do in this case, the now we'll do multiplication with y, and we'll shift this y to the here. So the dy by dx will be equal to the y, and we know the value of y, that is x minus 1 into x minus 2 into x minus 3. Then what we'll get in that case, so here we'll write directly. Okay, so if we'll put up this value and then multiply with the y in the first term, x minus 1 and x minus 1 will get cancelled out, and finally we'll have the x minus 2 in the first part, x minus 3, and the second part x minus 2 and x minus 2 will be cancelled out. The finally we'll get the x minus 1 into x minus 3, and the further so on. So here what we'll get, so x minus 1 into x minus 2, because the x minus 3 will get cancelled out the file this. So what we'll do here, so we know that now in this case we'll take the critical point, so we'll equate this equal to the 0. So let's put up equal to the 0 in order to find out the critical point. So now we'll just do multiplication here. So what we'll get, so x square minus 5x plus 6 plus x square minus 4x plus 3 plus x square minus 3x plus 2 is equal to 0. So after just simplifying this, 3x square minus 12x plus 11. So we'll get this value. And then now what we'll do, we'll try to find out the roots. So in order to find out the roots, we'll use the Sridharacharya formula. So we know that in order to find out the roots, so Sridharacharya formula, minus b plus b square minus 4ac divided by 2a. So let's put up this all value. So after putting, what we'll get here, so we'll get the value of x as a 12 plus minus b square. B is 12, so 12 square will be the minus 1 by 44, and the 4ac, a is 3, c is 11. So by 2 into a is 3, so it will be 6. So let's solve this further. 144 minus 132. Okay, so here what we'll get, so we'll get the 6. So finally we can say we'll get the two value of x. The one is the 6 plus root 3 by 3, and the another value is a 6 minus root 3 by 3. So we have found finally the two values. So what we'll do here in this case, so now after just simplifying it on putting the value of root 3, that is 1.732, and then we will divide by that numbers by 3, then what we'll get, in that case we'll get the 2.57, and in this case we'll get the value 1.422. Finally we can say we have found the value of x. If we now will put up this value, then what we'll get, so first of all, now what we'll do, after finding out the value of x and x values, now we'll differentiate this equation again with respect to x. So first we'll write that equation again and then we'll differentiate. Okay, so dy by dx, what was the function, the x minus 2, x minus 2, x minus 3 plus x minus 1 into x minus 3 plus x minus 1 into x minus 2. Okay, so what we'll do here, so now we have to again differentiate it with respect to x. So we'll write the differentiating with respect to x. So what we'll get in that case? So we'll simplify this first and then we'll differentiate. Okay. So after simplifying, we have found the after simplifying 3x square minus 6x 12x plus 11. So this was the value of dy by dx. So what we'll do here? So now we'll again differentiate it with respect to x. So we'll, in that case, we'll get the d2y by dx square. So what will be the value? 6x minus 12. So now we'll put up those value that we have found earlier, the value of x. Okay. So let's put up the value. So d2y by dx square will check at x equal to 2.57. 6 into 2.57 minus 12. In that case, the value of d2y by dx square is positive. It means it is giving the minima at this point, as we have discussed earlier that if the d2y by dx square is positive, then it will be giving the minima at that point. So now we'll check at the another point, that is d2y by dx square, that is x equal to 1.422. 1.422. So let's put up 6 into 1.422 minus 12. So in this case, we are getting the value of d2y by dx square as negative. It means it will be giving the maxima at this point. So first we'll write that. So here what we are getting, the positive value, it means minima, and at this value we are getting the maxima. Okay, so now what we'll do here? So it is asked that we have to find the ordinates. Ordinates refers to the value of y. Okay, so what we'll do? So first we'll put up this all value, the critical point, into the initial equation. That is this. So let's put up. So we'll put up the value. So y, we are calculating the y minimum value. Suppose minimum value. What will be the minimum value of y? So let's put up here. So the 2.57 minus 2.57 minus 1, because the value of x was 2.57. So here we'll put in these equations. So the 2.57 minus 2 and the 2.57 minus 3. Okay. So here what we'll get? So we'll get the 1, suppose it will be the 1.57 into 0.57 into minus 0.43. Okay. So after multiplication, what we'll get here? We'll get the value of minus 0.384. Okay. So it is the minimum value. Now what we'll do here? So now we have to calculate the maxima value that we are getting at point 1.422. So let's put up that value here. The 1.422 minus 1 into 1 minus 422, it will be the 2 at 2 1.422 minus 2 into 1.422 minus 3. So let's calculate. So first of all, what we'll get here? So we'll get the 0.422. Here it is fine. And here we'll get the minus of 0.578 into minus of 1.578. So what we'll get here? So we'll get the value again 0.3848. Here the minus and the minus will get positive, and here it will be the negative. It means we can say we have found the maxima and the minima value. So we'll write the y minima is minus 0.384 minus 384 and the y maxima as the positive value of this. It means 0.3848. So this is our final answer. So hope you found this solution understandable. Thank you.